Okay, by special request, I'm recording this because of Kaylee. It's a good idea. All right, so this is got a shout out on YouTube. What number is this? I closed my book. Number 2, and it's page 27. It is how it looks. Okay, we went through that. We went through that already before I started recording. I said they give you this distance from here to this corner, right? We went through a big long explanation of that. So watch. Instead of going from here to here, I just thought it was nicer to draw my triangle down here. That's the only reason I did that. All right? Do you understand that? I just didn't want my triangle being off to the side and all slanted like that. I just like my triangle looking like this, where my base is nice and horizontal. It just looks nicer. That's really, yeah, you don't have to turn sideways and look at it. I just like it like this. That's the only reason I did that. Everybody okay with that? All right. I didn't want to freak out. Okay, good. I didn't want to freak out over it, but there we go. Now, what did we do yesterday? There's a number that they didn't tell you that we can actually figure out.
The radius of the circle. Or not the radius, but the whole circle.
How about this?
360.
This is a big deal that we talked about yesterday, wasn't it? So look, it's 360 divided by, remember we did this yesterday? I went here, here, here. How many triangles would there be? There's 5 of them. There's the same number of triangles as there are, or some number of angles as there would be triangles, and the same number of triangles as there would be sides, okay? So it's 360 divided by 5. Did somebody do that for me? 72. We even used this number yesterday, didn't we? I believe. Wasn't it this class?
Yes,
I think it was. I did it at least once yesterday. I think it was this class. So watch. That whole angle right here is 72. But I'm not really going to use the whole angle. I'm going to use what of it? How much of it? I'm going to use half of it, which is this angle right here. So what's that going to be?
36.
It's going to be 36. Because I could have drawn a little bit bigger, but you can see it. Does everybody understand that? From the 72, because this bisects this big angle right here. Okay, so the whole big angle is 72, and we got that because we went 360 divided by 5. Do you understand why it's 360 divided by 5? Because, look, I'll just do this real quick. We did this yesterday, but I'll do it again. So, look, how many... If I went from here all the way to here, how many degrees is that? That's 360. How many big yellow angles are here? 1, 2, 3, 4, 5. That's why I went 360 divided by 5. Make sense?
Makes sense.
Okay, so that's 72. The whole angle is 72. But in order to solve for A and solve for X, I just need to find the angle inside my right triangle, which is 36. Everybody with me? Now look, it's a little small. Let's kind of blow it up a little bit. You don't have to do this, but I'm going to. Watch. Here and here. I'll just make it a little bit bigger so it's a little easier to see. Everybody okay with that? So what do we have? We got the bottom is X, this is A, this is 10, and this is 36 degrees. Right? So that's basically what we're ending up with right now. Now, we should know how to solve for A and how to solve for X because we had a whole chapter on this stuff. Okay, now you can't use Pythagorean theorem because you only know one side. Use this sine, cosine, tangent, right? Trig functions, that's right. So let's solve for, I don't know, let's solve for A first, okay, the apothem. So we know 10, which is the hypotenuse, and we're trying to find this side. This side, the apothem, is also the what? The adjacent side, isn't it? Just happens to both be A. So, no, you can't use tangent. No, not use law. This is a right triangle, so we're using our trig functions. You're the one that said trig functions. We're not using the law signs. We're using, what? This is adjacent, right? And this is hypotenuse. It's cosine. Adjacent and hypotenuse is what? Cosine. So, toa, right? We're using cosine to find this right here. All right, we're using cosine. You're not using ka. We just do that to remember that we use the cosine, but we're using the cosine. So let's do it. The cosine of 36 is adjacent over hypotenuse. Is this coming back to you? It was just last chapter. It was like less than a week ago we were doing this stuff. Multiply both sides by 10, and then put that into a calculator and see what you get. All right, so let's do that. Now again, the numbers that I gave you on that worksheet could be slightly different just on when you decided to round stuff, okay? We'll round it right here, though. So it's 10 cosine of 36, and that's, we'll call it 8.1, all right? Again, my number may be slightly different than what they use in the book. They may use that whole entire number in the book. I'm not really sure. But we're going to use 8.1. So remember, it's 1/2 the apothem times the perimeter. So guess what we just found?
The apothem.
We just found the apothem. So it's 1/2 times what? 8.1. Now we have to find what? The perimeter. Now how is x going to help us find the perimeter?
Because now we have
Half of one time.
You got half one of the sides, exactly right. Okay, you got half one of the sides. So we find x, right, and we double it, we got this full side. And then if I know the full side, there's 5 of them all together, and I take this multiplied by 5. Or if you wanted to, you could just take x and multiply it by what? 10. That's right. Right? Because you're going to multiply it by 2, then 5 anyway, right? So you could just think of taking x and multiplying it by 10. Does that make sense?
Yes.
Okay. So now we just have to solve for x. So let's solve for x. Let's do this in pink. All right. So what are we going to use here? This is opposite, and this is hypotenuse. We're going to use the sine, right? Because remember, it's opposite. We're going to use the sine. We're not going to use the law of sines. We're Pythagorean theorem. Yeah, but the problem with Pythagorean theorem is this. This 8.1 is a rounded number, isn't it? If I take a rounded number and square it, it becomes even worse rounded. You know what I mean? Because so I don't want to use a rounded number. Let's use the original numbers that they give us. Okay, I think it's better. I think it's a little more accurate if you do it that way. So we're using the sine. So we're using the sine of 36. Let me finish this. The sine of 36 equals the opposite, which is x, over the hypotenuse, which is 10. Multiply both sides by 10. X is, let's plug this in, it's 10 sine of 36. So it's 5.9. Tell you what, just for fun, let's do Pythagorean theorem with this just to see what it would have been. Okay, this is what we got. We got 5.9. All right. So what would you do? You'd go x squared plus 8.1 squared equals 10 squared, which would be what? It would be 10 squared, which is 100, minus 8.1 squared, correct? Equals. Take the square root of that. And it really came out to the same. It's not exactly the same, is it? Okay, but if we rounded it, it would have come out to the same thing. So could you have used Pythagorean theorem? Yeah, you could have. It wouldn't have been wrong. It would still round up to 5.9, wouldn't it? In that particular case, no, it wouldn't. Okay, that'd be fine. You could do that. But look, I mean, to me, I think using the sine is even easier than using Pythagorean theorem in that situation. To tell you the truth. All right, look, you already used cosine. You're doing the same exact thing, except you're using sine instead of cosine, right? That's all. So that's what x is. Now, what are we going to try to do here? We want to find the whole perimeter, don't we? So if x is 5.9, you could multiply it by 2, then 5, but just multiply it by 10. Do that in your head. What's that by 10? It's 59. All right? So that's the perimeter. And now we can find the area. Just multiply those 3 things together, and you got it. So watch. It's 0.5 times 8.1. Let's try it again. 0.5 times 8.1 times 59.
239.
Okay.
Round it, silly.
Yeah, yeah, the 9 rounds this up to a 9, and that would be a 0, so 239.0. So 239.0. All right.
Woo! I got it.
Well, you got to put them in the right way. You got to hit 36 sine, and then equals times 10, and then you should get 5.9, 5.8 something, right? Is your calculator in degrees?
I got it then, you know?
I don't know. You just didn't. You did something wrong. I don't know. Now, what answer did I give? I closed my book. What answer did I give for number 2?
239.
I did say that? Okay, good. So it came out just like the answer said. All right. Now, there are situations, depending on how you round this stuff, on all of these, you could be off just a little bit and still get it right. Okay? But on a test or quiz, I need to see this. I need to see that you used 8.1. I need to see that you put that number here, that number here. So don't just put the answer down. Like if you put like 247, you say, well, that's kind of close to that. I need to see where you got those numbers. Now, if you rounded like crazy to get this, I don't think you would have gotten that far. I don't think you would have been that far off. But if you just would have put 8, for instance, So if this was 8, half of 8 is 4. 4 times that is, I should be able to do that in my head, but 4 times 59 is 236. So you may have gotten 236 for this, but 236 might have been all right because you said you looked at this and say, oh, I just rounded it to 8. You follow me? So 236, if you would have written 236, and if I would have seen that you just put an 8 right here instead of 8.1, and you would have put the 59 and all that, and you circled it, I'd still give you credit for it, even though you're off by 3. That's what rounding does for you, okay? But let's just be consistent and round to the nearest tenth, okay? Then we'll all be pretty close to where we're supposed to be. All right.
Since we know
Does that
how
help?
to do the other ones already, can you do number 1 since that's a triangle?
Okay, let's do the triangle. And they just tell you one of the sides. Now, they do say it's a regular polygon. So what's true about all 3 of these sides? They're all equal to each other. So that's important, isn't it? Let me grab a... Yeah, because it says it's a regular polygon. Right? If it says it's a regular polygon, then all the angles are equal and all the sides are equal. In fact, if it's a regular triangle, it means it's equilateral. This is 8, right? So that's 8, and that's 8. If it's an equilateral or yeah, let's say equilateral triangle, I also know what all these angles are. What's this angle? We talked about this a long time ago. Look, all 3 add, yeah, they add up to 180, and if they're all the same, 180 divided by 3 is 60, right? So that's 60 right there. So what are we going to do?
Do we still use the same formula? Even though it's a triangle?
You could, but watch. I'm going to go back to my triangle formula. I think my triangle formula is a little easier.
That's what
okay? But you could do that. I think you just using 1/2 the base times the height is a little bit better. All right, on a triangle. Because the apothem would be here, and then you're going to have to find this length, and then you're going to have to find this length. I just think it's a lot easier. Don't do the apothem thing. I would just, on a triangle, I would just do 1/2 the base times the height. So if this is 60, this is what? 30. All right, this is the height. I know the base already. What's the base? It's 8. So it's 1/2 times 8. And now all I got to do is find the height. It is 30, 60, 90, isn't it? All right, this is the hypotenuse. What's the short side? If this drops down perpendicular, that short side is 4, isn't it? Because look, the hypotenuse is twice the short side. What's the height? It's 4 times what? The square root of 3. See, memorizing those things, right? Remember that? We talked about that yesterday. If you memorize that the long side is the square root of 3 times the short side, it makes it really, really easy. And so you just plug all that stuff in your calculator, and you should be good to go. Half of 8 is what? 4. 4 times 4 is 16. So I can just go 16 times the square root of 3. And that's 27.7. Is that what I gave? What did I give as an answer?
27.7.
There you go. So that wasn't so hard, was it? You got to read the instructions and know what they're telling you. It says it's a regular polygon, so you need to know that all 3 of those sides are 8. Which also tells you that this side, this angle is 60. This whole big angle is 60, but what do we do to that angle? We bisect it, right? So that's got to be 30. We also bisect this side, so this has to be 4. Got it?
Got it.
So that wasn't so hard once you think, right? You got to sit and you got to think a little bit. It doesn't come to you right away, but you got to start asking yourself some questions. Okay, it's a regular polygon. It's a triangle. What do I know about a regular triangle? Oh, I know that all the sides are equal. I know all the angles are equal. So I can find all that good stuff. All right? What's that? Yes, absolutely. That's the definition of a regular polygon. We discussed that yesterday, too. All right? Does that make sense?
Yeah, I got the wrong answer because I used 4 for the base instead of 8.
Okay. All right. What about this one? How many sides? 1, 2, 3, 4, 5, 6. Hexagon, and it's kind of tilted up like that. Hexagon. That's a hexagon right there. And they tell you the apothem, right? So they tell you half of it. So really all you got to find is the perimeter. We're doing this one. 3. You don't really need to... I mean, they make it look like that, don't they? You don't really need to make it look like that, do you? I kind of like it like this because I like to do this. I like to do that, and I like to do that. And you say, wait a minute, they didn't draw that in my picture, did they? Oops. Why did I make that blue? I didn't want to make that blue. Let's keep that one white, and let's make the apothegm blue. Or let's make it yellow so it stands out a little bit better. We'll make it a little thicker so it's a little brighter. There we go. Oh, look how bright that is. All right, so what are we going to do? What do they tell us, first of all? They tell us the apothegm, don't they? Well, that was nice of them. So the apothegm is, what, 6? So really, what are we trying to find? We're trying to find the area of this, so it's 1/2 the apothegm times the perimeter. Well, they tell you the apothegm, so watch. It's 1/2 times 6 times the perimeter. So I got to find the perimeter. So in order to find the perimeter, I need to find this length right there. Everybody see that?
Yes.
I mean, that should have occurred to you, right, when you're looking at this, trying to figure it out. So that means we have to find this little segment right here, don't we? All right. Yep. So let's find this angle up here. Well, it's a hexagon, isn't it? 6 sides. So what's that big angle from here to here? 360 divided by 6, which is 60. So what's the little angle? It's 30. Oops. Right. So that is 30 right there. I'll tell you what. Just you don't mind if I draw a little bigger, do you?
Sir? No.
Sometimes when you draw it in the picture, it just gets a little bit messy because it's so small. So what is that? That's 30. We're trying to solve for that, right? And you know this is 6, and you know it's a right triangle. All right? And this would be 60. Yeah, let's use the long short stuff, okay? You're trying to find the short side. This is the long side, so how do you, if you know the long side, how do you find the short side?
Can't you do 10?
10? The tangent? You could do, yeah, you could use a trig function if you wanted to, absolutely. You could use opposite over adjacent. Right, I would do that way, Scrap. I would go 6 divided by the square root of 3.
But you can't have a square root.
Well, but we're going to put it into a calculator anyway. It's no big deal.
All
right.
You don't leave it like that.
Right, as long as you don't leave it like this, you put it into a calculator, you're fine. All right. So that is 6 times the square root of 3. That's just this little bit right here. If I want to find the whole perimeter, watch, 6 over square root of 3 is just this little bit right here. You could times it by 2, but then you're going to have to multiply it by 6. Or you could just take this and multiply it by 12. Right? Either way it would work, right? Times 2 times 6, and the same thing as times 12. So if you wanted to, you could just multiply it by 12. It'd be the same exact thing. So that would be what? 72 divided by the square root of 3. That's your perimeter. And so you could take that number and put it in right here. 72 divided by the square root of 3. Okay? And now you can just plug that into a calculator and get an answer. Half of 6 is what? 3. So it's just 3 times that. So let's do it. It's 3 times 72, right? Divided by square root of 3.
I got 1.
Is that the answer? 124.7?
Yes.
Yeah, when you do it with tens, you get a different.
Okay, I know. But we talked about that earlier, right? It could be slightly different. It could be slightly off, but it shouldn't be that far off. What did I do the bottom to what? What? Right here? Were you listening? Look. The perimeter, listen. I'll say it again. Hush, don't talk. I'm trying to answer a question. Guys. The perimeter is the distance around the whole thing, right? I found this, which was 6 square root of 3. Okay? We said this a couple times. You could take this, multiply it by 2, right, to get the whole side, but then multiply it by 6. Or it would just be easier just to multiply it by 12. That's what I did right here. 6 divided by the square root of 3 is this x. If I multiply it by 12, I got the whole perimeter. That's the whole perimeter right there. So that's what I put in for the perimeter. Put all that into a calculator, and that's what I get. All right, let's go back. Some of you guys were going to use the tangent on this. Let's see if we get the same answer if we use the tangent. All right, and you should, right? If you don't, you did something wrong. Now, it may not be exactly to the decimal. It might be off depending on how much we rounded it, okay? Because look what we did. we put an exact answer into our calculator, didn't we? We didn't put a rounded answer into our calculator. So our answer could slightly be off just a little bit. So look at this. Which angle do you want to use? You just use the 30 since we're already up there. So let's use tangent. So the tangent of 30 is equal to opposite, which is x, over the adjacent, which is 6. Multiply both sides by 6. Let's put that in and see what x is. Now it should come out to whatever 6 divided by the square root of 3 is, right? So let's see.
When I do it the way you just did it, I got the same answer you got.
Well, good. Well, you probably didn't do it right the other way. You probably made a mistake somewhere. What did you use? The 60? Did you use the 30? Did you put x over 6? Like this? Well, I don't know what you did wrong. Did you multiply both sides by 6? Well, you should get the same thing. Okay, well, let's see what we get. That's what I'm doing. 6 tangent 30, right? And that's 3 point. Now, again, it depends on how you round, right? On your final. So if you round it to 3.5, it may come out a little bit different. So x is 3.5. Let's say you rounded it to 3.5. Now, what do you do to find the perimeter, though?
You gotta
Times it by 2, then times it by 6. Or you could just take 3.5 and multiply it by 12. Does that make sense to you? Times 2 times 6, right? That's 12. So let's put that in. So 3.5 times 12, that's 42. Let's multiply that. That was our perimeter, right? Okay, so that was 42. Multiply that by half of 6, which is 3, so 42 times 3, let's go there,
That's what I got.
is 126, and that's fine.
That's fine.
Yeah. Yeah, we talked about, we've had that discussion. Is anybody listening to me when I'm talking up here?
Yes.
The first time, anyway? All right, look, I said there's definitely possibilities of getting slightly different answers depending on how you did it, right? All right, that's a slightly different answer. Now, look, if I would have got 378, do you think that would have been close? No. All right, so, I mean, what is close? I don't know. But I think 126 is pretty close to that, don't you? Yeah. And why did we get 126? Because we rounded that to be a 3.5.
If you round the answer that you gave us, it's only one off. So.
All right, so watch. That 3.5, that x should be the same thing as 6 divided by the square root of 3. Let's see if it actually is. That's kind of fun. 6 divided by the square root of 3. And let's see what that is. Boom, there it is. Look at that. That rounds to 3.5, doesn't it? But when we got our initial answer, though, we didn't round it, did we? We put it in to our formula just like this. Make sense? So it all depends on what numbers you put into your formula. Do you put in an exact answer or do you put in a rounded answer? That determines whether your answer is right or not. This would be perfectly acceptable. If this was the answer in the book or in my answer key, if I did this problem like this and I got 124.7 and I saw 126, you know what I'm doing? I'm looking at your problem to see, because you should be showing your work. I'm looking to see how you got that. If I see that, okay, then I see that you did it right. All you did was round. So you're fine. You'd be perfectly fine with that.
Do we not
Okay?
need to worry about 5 through 8? Because that's all weird ones. Yeah.
Oh, no, you should do that. We talked about it a little bit at the beginning.
This is how you
Abby,
do
does Shane please come to
that?
the office?
Yes, exactly. I tell you what. Listen. Let me just show you something real quick here. Okay? These right here, what you're going to do is this. You're going to break them down into things that you know. Let's make this a little bit bigger. Look, everybody watching? Yes. So look, what do you have? You've got a rectangle, 5 times 12, right? You've got a triangle, so you're going to have to find the height, though, aren't you? So that right there would be the height. What would the height be? If that's 5, the whole thing is 20, then the height is 15. What's the base of it? It's 12. So you can find the triangle, and then you find the rectangle, add them together. That's what you're doing on all of these, okay? Finish this up on Monday.
Thank you, Mr.
You're welcome.